remember, like for this lines, angles, and polygon, not only lines, angles, polygon, even entire geometry. Entire geometry, you need to remember many things, but overall, it's easy concept, right? So just set your mind. Maybe you need to memorize or you need to revise many things related to this, and everything you have to keep in your mind when you deal with the data sufficiency problem or problem solving problem or any kinds of problem. So you need to remember many things, but things are not difficult. That's the point I wanted to make here. Maybe you need to remember many things, but things are not difficult. So let's start. This is the plane geometry, and the first topic what I'm going to start is lines, angles, polygon, and triangles, right? So what is point? If I ask a point, how you define a point?
It's a point in the space, like a...
Yes, a point is an object, not in a space, in a plane. So point is an object in a plane which has no length, no width, no height, no depth, but still exists. Or you can say point looks like circle whose radius approaching to 0. So I'm saying point lies in a plane. So what is a plane?
A surface.
Surface, correct. Plane is a surface, like this computer screen is a plane. Your notebook is a plane. My whiteboard is a plane. Okay, this earth is a plane. Okay, plane has no end. So that is the point, right? Now let me take 2 points, P and Q, and join them and extend infinitely. So what is this? I extended infinitely from this side to this side. This is called line. And if I extend only one side, I do not extend once, this is called ray. And if I just join the point, do not extend. So this is called line segment. Hope this 4 points, 5 points is clear. Plane, point, line, ray, line segment. So what is the line segment? Part of the line is called line segment. Part of the line is called line segment. Right. Shall I go ahead?
Yes.
Now we are going to see the parallel lines. Parallel lines.
Yes.
When two lines never meets, or you can say when the distance between line wherever you check, it is constant, they are called parallel lines. Also, we can say the angle between these two lines theta is 0 degree. They are called parallel lines. Next one is the perpendicular lines. When the angle between two lines theta is 90 degree. This is also called right angle. This is perpendicular lines. A simple way of understanding a horizontal line intersected by vertical line, so they are perpendicular lines. And when they, this is the sign of perpendicular. Sometimes they write 90 degrees, sometimes they give this sign. So this sign indicates that the angle between these two lines is 90 degrees. Right? Intersecting line. You can see here one blue line intersecting a red line at the point P. This is called intersecting line. And you can see whenever line intersect, they make some angle theta. Intersecting line. Just a minute. Now, when two lines intersect, you can get 4 angles. This, and this. And this pair of angles are called vertically opposite angles. And vertically opposite angles are equal, means angle 1 is equals to angle 3, and also angle 2 is equals to angle 4. They are vertically opposite angles, and vertically opposite angles are equal. Next one is the linear pair. What is this linear pair? Pair of angles
complementary
on a line. Pair of angles, you take one line, and on this, if you take like this, you get two angles, right? Maybe theta 1 and theta 2. This theta 1 and theta 2 is called linear pair, because on a line we have pair of angles. So linear pair. A linear pair angles always sum to 180 degree. Linear pair angles always sum to 180 degree. Now we'll go to the transversal line. What is transversal line? A line that intersect at least two lines in a plane. A line that intersect at least two lines. So here you can see I have three parallel lines, L, M, and N. Here I have three lines, L, M, and N, right?
Yeah.
And you see this line, give any name, P and Q, whatever name you give. So line P intersect all these three lines. Line Q also intersect all these three lines. So the line is intersecting, they are called transversal line. The line which intersect at least two lines, they are called transversal line. Transversal.
Yes.
And it is very obvious if the lines are parallel, then obviously the distance from here to here be same from here to here. Similarly, the distance from here to here be same from here to here. So this ratios or this relation can be established. A by B divided by B by C is same as D by E divided by E by F. Good. I'm sure you know all these things. This is just kinds of revision, right?
Yes.
Yeah. Supplementary angles. When the sum of two angles is 180 degrees, they are called supplementary. Let us say this is theta 1, theta 2. If theta 1 plus theta 2 is equals to 180 degree, they call supplementary. When theta 1 plus theta 2 is 90 degree, they are called complementary. You can see there are many angles, alpha, you can give any name, beta, gamma. These many angles start with the same point. The angles start with the same point. They are called co-initial angles. Co-initial. Many angles starting with the same point. They are co-initial.
Okay.
Now we'll discuss more about transversal. Let us say there are two lines L1 and L2, they are parallel. And I'm taking a line which cut these two. So this line is called transversal. Transversal, V-A-R-S-A-L, transversal line, right? And when two parallel lines intersected by a transversal line, we can see there are many angles, A, B, C, D, E, F, G, H. There are 8 angles. We are going to have deep discussion about these 8 angles, what they are called, how they behave, etc. This one. So out of 8, the angles are interior region, they are known interior angles. Outside, exterior angles. You can see these four are interior because they are inside, and they are outside, so exterior. I'm sure interior and exterior is clear.
Mm-hmm.
Now corresponding angles, that's very interesting one. Corresponding angles means if angles are at similar position, so we call it as corresponding. Like if you see a line, I'm taking this, as case the line, so this is the similar position.
Mm-hmm.
So this B correspond to this, and here angle B and angle F are equal, provided lines are parallel. If lines are not parallel, we can't see. So here I'm assuming or provided lines are parallel. Provided lines are parallel. If lines are parallel, so this B correspond to this B correspond to this B correspond to this. So means you are going to get four pairs of 8 angles. And these all corresponding angles be equal. But all corresponding angles are equal.
Yes.
Any questions so far?
No.
Good. Let's move. So whatever we discussed, let me few more things. Interior alternate angles. Even when you see the inside angle, so this black and black be equal. This pink and pink be equal. Interior alternate. Similarly, exterior alternate. This be equal to this be equal to this. Note, every time I'm keeping lines are parallel. Note, lines are parallel. If lines are not parallel, this idea will not work. And this corresponding, we already seen, this be equal to this, similar position, this be equal to this, similar position, this be equal to this, similar position, and this be equal to this, similar position. Yes?
Yes.
Provided lines are parallel. Now polygons. All right, one line definition for polygon. Closed geometrical figure. I'm telling one line definition for polygon. Closed geometrical figure formed by 3 or more line segments. Closed geometrical figure formed by 3 or more line segments meeting at their endpoints called polygon. Closed geometrical figure formed by 3 or more line segments meeting at their endpoints called polygon. So I'm going to sketch some figure. You just tell me, is it polygon or not? So you have the definition of polygon. Closed geometrical figure formed by 3 or more line segments meeting, this last point is very important, meeting at their endpoints is called polygon. So now you tell me, is it polygon?
No.
Yes, no?
No.
Congratulations, you got right answer. It's not a polygon. It's a star. Is it polygon?
No.
Congratulations, you're right. Is it polygon?
Yes.
Sorry. Still no. The reason is
because
I
it's
said
not a line.
line. Where is the line? This is a zigzag. This is the curve. This is not the line.
Yes, yes.
One more. This is the polygon.
Yes, it's close there or not?
Congratulations, it's a polygon. So hope you understand what is polygon, what is non-polygon.
Mm-hmm.
Is it polygon?
No.
No is right answer. So okay, so I understood, you understood the polygon. Now in the polygon, there are three categories. Category one, convex. So write one line definition for convex polygon. In convex polygon, all angles are less than 180 degree. In convex polygon, all angles are less than 180 degree. When I say angle, by default, interior angle, like this. In convex polygon, all angles are less than 180 degree and all diagonals are inside the shape.
Mm.
All angles are less than 180 degree and all diagonals are inside the shape. Next one is the concave. At least one angle is more than 180 degree. At least one angle is more than 180 degree and at least one diagonal is outside of the same. At least one angle is more than 180 degree and at least one angle is out of the shape.
Yes.
Okay. Next one is the regular polygon. Regular polygon is very important. You can write in regular polygon, all angles and all sides are equal. In regular polygon, all angles and all sides are equal. And definitely they will be convex polygon. And definitely they will be convex polygon.
Mm.
Regular polygon is also known as equilateral or equiangular. Regular polygon in the GMAT club or GMAT book somewhere they use word the equilateral polygon. So for regular sometimes they use word regular, sometimes they use word equiangular. Equiangular means all angles are equal.
Mm.
And if the polygon is not regular, this is called irregular. If the polygon is not regular, that is called irregular. Is that clear?
Yes.
Good. Now have a closer look how polygon looks and what are their names. Take 30 seconds and memorize this. I'll be back in 1 minute.
Okay.
So is all different kinds of polygon is clear, their names: three-sided triangle, four-sided quadrilateral, five-sided pentagon. And you notice one thing. Okay, let me ask also, in this, which one is the convex and which one is the concave? By looking figure, can you decide? Just tell me which is the concave by looking the figure. But let us assume the shape given is drawn to scale.
Okay. The concave, you're asking?
Concave, yeah.
The decagon.
Correct, because here we have more than 180. This is also, right? You can see this is also more than 180 degree.
Yes.
So these two are concave and remaining are convex. But it doesn't mean that pentagon cannot be concave. Pentagon could be concave. Even quadrilateral could be concave. Shall I show you how quadrilateral be concave? You see this is the quadrilateral, but this is concave.
Yes.
Right? Because if you see this angle, this is more than 180 degree. So the idea is, it depends how you sketch. I just talk about the way picture is given. By looking the picture, here only two are concave. One is nonagon and decagon, and rest are convex. But even every polygon could be concave, except this. This cannot be concave because here the sum of all angle is 180 degree. So how one angle be more than 180 degrees? So this is not possible. So except triangle, every polygon can be concave. Frederick, is clear?
Yes, yes.
Now we'll talk more about the polygons. Here I have taken a polygon. You can see this polygon is called, give some name, A, B, C, D, E. What this is called? Pentagon, because we have 5 sides, 5 angles. This is called pentagon. In any polygon, whatever be pentagon, triangle, quadrilateral, whatever, in any polygon you will find 3 types of angle. One is angle. This is called interior angle, but by default we say angle. So by default we say angle. Actually the name is internal angle or interior angle. Okay. Second one is the exterior angle. This is the exterior. What is the exterior angle? Simply extend one of the side and the angle between extended side and adjacent side is called exterior angle. So how many exterior angle we get in the pentagon?
5.
5. Obviously you extend every side. Extend this one, extend this one, extend this one. So 5. Give some name. Let us say this is A dash, B dash, C dash, D dash, and E dash. Do remember sum of exterior angles is always 360 degree for any polygon. So A dash plus B dash plus C dash plus D dash plus E dash is 360. I repeat, it is not only for pentagon. You take any polygon, sum of exterior be 360. Even you can take the triangle, how it looks here. This is the exterior. This is the exterior. This is the exterior. Am I right? Let us say this is A dash, B dash, C dash. So what is A dash plus B dash plus C dash? 360. So whether you take pentagon, octagon, hexagon, nonagon, decagon, anything, sum of exterior angle be always 360 degree, 0.1. Now you can see the center angle. This is a center angle, one of the center angle. And if I, so how many center angle we get if I join all vertices for this?
5.
5 center angle. Let us say this center angle is C1, C2, or take theta 1, theta 2, theta 3, theta 4, theta 5. And sum of all center angle be always 360 degree. This be also 360 degree. Irrespective of the polygon. Whether you take quadrilateral, you take triangle, pentagon, octagon, hexagon, decagon, always 360.
Mhm.
See, you can take a center somewhere here and join all this to this, this to this, this to this. How many center angle we're getting? Theta 1, theta 2, theta 3. Even the sum of these 3 be 360. Theta 1, theta 2, theta 3 be 360. I hope it is clear.
Yes.
Now I'm adding one very important point. Listen. If the polygon is the regular polygon, regular means all sides and all angles are equal. For regular polygon, for regular polygon, each exterior angle, you know how much? 360 divided by n. N is the number of side. Number of side of polygon. Isn't it? If the polygon is regular, means this angle, this angle, this angle all be the same. So what is each angle? 360 in case of pentagon, 360 by 5. In case of triangle, 360 by 3. In case of decagon, 360 by 10. Right?
Yes.
And not only exterior, even center angle. If the polygon is a regular, then even each center angle, each exterior angle, or you can say each center angle, same 360 by n.
Understand.
So center angle, exterior angle is very clear. Now the most complicated part is interior angle that we are going to discuss now. We are going to discuss interior angle. Read this. Let's talk about the interior angle. I have formula, I'll show you the formula, but I just wanted you to understand here. Let's take a triangle. A, B, C. This is called interior. So sum of all interior angle for triangle be 180. If you take quadrilateral, A, B, C, D. For quadrilateral is going to be A plus B plus C plus D is 360. Here 180, just added another 180. For pentagon, you increase one side, so add another 180. A, B, C, D, E. What is the sum of all angle? A plus B plus C plus D plus E is another 180. So 180 plus 180, 360, 360 plus 180, 540. Is that clear? Now you can see interior angle is changing. It depends on the number of side. But exterior angle and center angle was not changing. Whatever be the number of side, it was same. So here I will write formula sum of interior angles. Pratik, I already said interior, sometimes they don't use word interior, simply they say sum of angles. When I say angle, okay, by default, it means to interior. Okay.
Interior. Okay.
Sum of interior angles. Formula is n minus 2 into 180 degree. What is n here? Number of sides. Number of sides in the polygon. So if I say hexagon, can you tell me what be the sum of all angles of hexagon? Hexagon.
Wait. Hexagon. 6. No, sorry.
Do calculate and get the answer. I'm asking sum of all angles of hexagon.
720.
Sorry?
720.
Correct. Correct. You copied all?
Yes.
As I told you, for geometry, you have to have the patience. There are so many things, but things are easy. But that so many things may create, increase the difficulty because there are many things.
Yes, yes.
But overall, the concept is easy.
Okay.
And these all many things, it should be on the brain, because when we deal with the problem, everything should pop up automatically. Then only you'll be able to, now have a look at this one, and I'm sure this will be clear to you. What is doing here is, if you take 3 point A, B, C, this is 180-degree triangle. We take 1, 2, 3, 4 points, so it's became quadrilateral. We take 5, pentagon. You remember I told you it keeps increasing.
Yes, yes.
180, 180, 180. Right. Just have a look and say it's clear.
Yes.
Clear?
Mm-hmm.
This point we already discussed, right? Exterior angles, sum of exterior angles. So I go ahead,
Yes. Mm-hmm. Yes.
Now the diagonals. We are going to talk about the number of diagonals. Before I take this figure, let me understand. If I take a quadrilateral, how many diagonals are there?
How many?
Diagonals. Do you know diagonals?
Ah, yes.
Diagonal.
Yes, yes. 2.
Correct. One is this. One is this. This is the quadrilateral ABCD. If I take the pentagon, 1, 2, 3, 4, 5. This is the pentagon A, B, C, D, E. For pentagon, how many diagonals you have?
You have
Just I'll show you.
3.
1, 2, 3, 4, 5. So here diagonals was 2, here diagonals is 5. So how to count the number of diagonals in the given polygon? So let me write here is number of diagonals. D is equals to, formula is n into n minus 3 divided by 2. Number of diagonals, n into n minus 3 divided by 2. What is n? Number of sides. Is that clear?
Yes.
Copy fast. And you can copy the formula in the next page. It is given. This one.